Hi, Carl here from Hyrel again. We've had a lot of fun making some videos recently, and some questions have come back. And so today I'm going to try to explain how to use two heads in concert using cloning. And then I'll follow up with a little fun configuration that we can do. So first, I've laid some heads out here on our table. These are a couple of SDS heads. They're used for dispensing liquid. And these are Uvada pens. Uvada is a company that makes a beautiful focusable light source. We've demonstrated that in a previous video. But these can come at 365 nanometers, 405, and 450 nanometers. So the wavelength of the light reacts better, more efficiently with different types of chemistries. So you picked your wavelength of light to match the type of polymer that you wish to cross-link. In case cross-linking is not clear to all of you, if you have two carbon chains, it creates a polymer. Polymer meaning poly, and it repeats itself. So it's a carbon, 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 carbon like this. They literally look like two ropes laid next to each other, but on a molecular level. Well, two ropes would slide back and forth real easily, like this. So you can see that. And now what we want to do, that's a liquid when they're sliding easily. But we want to lock them up and make them into a solid. So what it is there's a carbon, 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 another carbon, carbon, carbon. And what they do is we hit it with light, and there's a little special chemical called a photoinitiator, and that breaks the bond that's on the end of this carbon and breaks this bond, and then causes them to go together. And now there's a link between them. That's why they call it a cross-link. Once it's cross-linked, it can't move anymore, and it becomes solid. All right, so that's how we go from a liquid to a solid and create a polymer that's rigid and has better properties. It's not liquid or more desirable solid properties. Sometimes this cross-linking is done loosely, and we get different properties such as a sponginess, a flexibility to it. And that's very important. The more the cross-links, typically the more the stiffness of the material. So let's start, and we're going to actually take and dispense a liquid, and while we're dispensing the liquid, we're going to hit it with ultraviolet light. I'll use this one for that example. And so typically it works with any of our printers. Literally, this particular experiment would be fine. And we're going to put the SDS, syringe dispense system head, here in slot 2. And now I'm going to put the Uvada light pen over in slot 4. Let's see, I make sure this has got to be out of the way. There it is. Now you can see the displays come on. It's a 0% duty cycle. The current I set is set to approximately 1 amp. And what we do is we pulse width modulate the duty to get an effective integrated light intensity. So first thing I'll do is I'm going to turn off the bulb here. So this is our build plate. And I'm just going to test. You'll see that once we plug these in, the SDS has showed up, and so has the Uvada light pen. So I'm going to enable the power and then just turn it on. You can see the pretty color of blue. If you're using the 365 nanometer light pen, do not look at it for long periods of time. It will hurt your eyes. It's always best to do this inside of one of our enclosed units if you're going to be doing much of this, or wear safety glasses. That way you'll be protected. Okay, so now that we've done that, the big question is, how do I cause that to be synchronized with the print? So typically we do a thing called cloning. And what cloning does is it says, make this head here act the same as this head here. Well, at first you're going, well, that's light and that's liquid, so how is that possible? So when there are two different technologies, one's dispensing and one is illuminating, we have a state that it goes into. So let's just look at the printing side for a second. When you're printing, we're idle mode, we're not doing anything, or we're getting ready to print, which means we're loading the liquid into the tube or starting the syringe to drive down. That's called the prime. And then we're actually printing, so that's running, okay? At the end of your move, we have to suck back a little or you get a big blob. That's called the unprime. So it's prime, run, unprimed. Every type of move that starts and stops a print, whether it's us, whether it's plastic, whether it's liquid, follows through these steps. Well, this right here, the light pen, also says it's priming, so let's turn on the light. It's running, let's keep the light on. It's unpriming, and so we turn the light off. And there are millisecond level of parameters you can actually program into your head and flash them, and that becomes the default as to how many milliseconds it will prime, how many milliseconds it will stay at the unprimed time as well. Okay, there's also on the screen the ability to move, which, let's see if I can take you there with my big fat fingers, BFF. And you'll see right here, it says, oh, that's, what does that say? Right settings? No, we don't want that. Back. Clone. See where it says clone off? That means it's not cloned at all. But if you press it once, that now says this is cloned to position 1, but there's no head there. And now I'm going to say clone again to position 12. That would be yoke 1, position 2. That's why it's called 12. And that's correct, so we're good to go. So now what I'm going to do is I'm actually going to hold my finger down. Up pops this thing, and I'm going to flash this head setting, confirm it. And now that will be cloned to this. That means that this head is cloned to here, and whenever a command goes to here, this guy sees that command and he will obey it as well. All right, so in theory, if we did this right, we only have one more thing to do, and that's add some enable code here so that the head will come on. There should be an M620 and an M621. Okay, you guys might like this. I'm old and I have trouble seeing this small print. If you hit Control and plus while you're in this editor, the print gets bigger. So now it's a lot easier for me to see, and hopefully it's easier for you to see too. I can see that this is an old piece of code here. Somebody left some comments where they shouldn't have. So I'm going to come in here. There's your 620, your 621, and your M703. M703 is actually a clone command. What it says is clone head 12 to head 11, which is completely wrong, which is why we're going to comment it out, and we're going to let the auto clone take care of it for us, where we've set this clone head up here, and you don't have to worry about putting it in your code. Okay, so now whenever there is an E, which means extrude, to the head, that will also turn on the light here. So let me save this. Is it okay if I save it? I'm going to save as. I'll give it a name. I'm supposed to get a keyboard. How do you get the keyboard? Do you go down to the bottom to get the keyboard here? Oh, well, okay. You're going to make me do it the old-fashioned way. We'll call this UVADA clone H14 to H12. All right. Okay, well, let's just hit the print button and see what happens. Okay, it's telling us, okay, that's a good thing. Let's just stop that now. One thing that was missing from this is, or incorrectly done. Nah, it's good that we show you this. When we have a master head or any head, oh, it's actually trying to print now. Okay, fine. We give it a T argument to say which head is supposed to be doing the printing. This code had T0 in it, meaning it expected the master or SDS head in slot 1. But we're actually in slot 2, and that would be T1. I know it's a little confusing, but that's the way we numbered it for the T command. The T command is a T on the very first character of your line, and that says which tool is working at that time. All right, let's try it now. Well, here you can see that the UVADA is synchronized with the print head, and you'll see that the duty cycle is coming up and down. So duty means it's on or off based on what it's supposed to be doing. That's just a little quick circle for us to test this out with. Your prints could run for hours. It depends on what you're trying to do. Okay, so that's cloning one unit to another. Now the next thing I want to do is I want to show you how we would set this up in a more complicated way. So what I'm actually going to do is I'm going to move to another printer. So first I'm going to remove my heads. And here you'll see that the light will go down to the tip. If you need more of an angle, we have other items that are printed so that you can come over and bring them at more of an angle. What I'm doing here is I'm going to set up two materials. So I have two syringes and two Uvadas. And the reason why this is interesting is because you can run two different materials that require two different frequencies of light to optimally operate. And now you can dispense with this one and then this one and use different UV light for both of them. So two completely different material science problems or solutions in this case. One could be harder, one could be stiffer. Now, in this particular case, we have a problem that sometimes comes out, and that is it's difficult to get the tips of these adjusted just exactly perfect. So we have a solution for that, and it's called the lifter head. And the way the lifter head works is, this actually is the same width as one of our slots. It has a high current capability. We plug it in by just sliding it in here. This would go over and it plugs into the yoke, which is right there, which I hope I get right. Sorry about that. Well, let's just slide it out and look at it where I can get to it. Sorry about that. There we go. All right. And now you take your head. Now this can go up and down. And you'll see it's not set up for the lifter yet. So now your head that we want to have as being your secondary head will plug into here. Good. So you can see that now we can move this up and down. It moves about 20 millimeters with this. And we just give it a command to go up or a command to go down. And then the Uvada light pin comes on a bar, and we have extended version of this that plugs in here, and so your Uvada light pin can also be right at the correct spot for doing that. That's how you would have two different types of materials easily printing with just the XY offsets. It's a little bit tedious to set up. It takes 20 minutes, 15 minutes to get this perfected. After that, it runs easily and it's very repeatable. So that would be a case for using two different liquids, two different frequencies of light, and having a lifter so that you don't have to fight where the tips are being aligned or not being aligned. Okay, I got one last configuration that we actually patented many years ago, and that uses a liquid. Whoops, sorry about that. That's me not being careful. And also a solid. So what we can do here is, and again, we can come in with, and I hope this works, because I haven't tested it yet. Much easier if you program this in. And I'm going to put this right here. And we'll tighten it. And now we take our regular FH2 filament head, and we bring this around. Sorry about that. I know it fits. There we go. All right. So now you have a filament head and an SDS. And what is commonly used for this, what our patent is to create a profile using the ABS or PLA, other types of materials, whatever makes good sense to you. And then we come back and we fill it in with a liquid. And so this acts like a on-the-fly mold. So you can print your mold, put your liquid in, cross-link your liquid, and then either keep the ABS on the outside, or if you print it with PLA, you can dissolve the PLA real easily, and now you end up with your polymer that you printed in any shape that you decided you want to print as the peripheral of it. So think of it as a swimming pool that we can print the outside, fill it in, make it hard, and then dissolve the swimming pool away. All right, there's a couple of good examples on what our printer can do. Next week, we hope to show you how we do this using carbon fiber and two-part epoxy resin. So I hope you have a good week, and thanks for watching.